concept of a function. Any physical quantity is represented by a function in mathematics is concept of a function. Now we will see an example. Approach, you can clearly understand this statement. Now let us consider from morning to noon. From morning to noon, temperature increases, time also increases. From noon to night, as time increases, temperature is decreased. For example, at 8 a.m., the temperature is 40 degrees Celsius, and at 9 a.m., the temperature is 60 degrees Celsius. What is the change in temperature? (60 minus 40) is the change in temperature is 20 degrees Celsius. Suppose if I relate this change in temperature with respect to time, here 8 o'clock, 9 o'clock. What is the difference of time? 1 hour. So if I relate this temperature with respect to time, then I can call it as rate of change in temperature. Rate of change in temperature. Suppose if I am asking at 8:30 a.m. at 8:30 a.m. what will be the temperature? Suppose it will be 50 degrees Celsius. Then I can call it as instantaneous rate of change in temperature. Rate of change in temperature at particular instant or at particular time. Then I can call it as instantaneous rate of change in temperature. Clear? Now, this temperature depends on time. That is, this temperature is a variable. The time is also variable. This temperature, it depends on time, so I can call it as dependent variable. This time doesn't depend on temperature, so I can call it as independent variable. If I relate these two physical quantities, I can write temperature is equal to function of time. I can relate these two variables, that is temperature is equal to function of time. Now you see this statement, any physical quantity is a temperature, physical quantity, time is a physical quantity. This is represented by a function f in mathematics. This will be represented in the form in mathematics. So temperature is equal to function of t, that is time is independent, so t is dependent. So t depends on time. Clear? So next, what is flow? How much it is inclined, that will give the flow. That is how much this line has been inclined. Okay. Now let us consider a function y is equal to 2x. Now find the interval x, y equal to 2x. If x is equal to 0, y will become 0. Suppose if x is equal to 1, y will become 2. If x is equal to 2, then y is equal to 4. If x is equal to 3, y is equal to 6. Now you plot the points in the graph. So x, y. For 0, this one is 0. Then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. For 1, it is 2. For 2, it is 4. For 3, it is 6. So, now we are getting a straight line. Now I want to find out the slope for this. See, in lower classes you study how to find out the slope for the two given points. Now I want to find out the slope for these 2 points. So what is the formula for finding out the slope? y2 minus y1 divided by x2 minus x1. So this will becomes x1 and this one x2. This is y1 and y2. The difference of y2 minus y1 is nothing but what? Delta y. The difference of x2 minus x1 is delta x. So I can write y2 minus y1 is equal to delta y. This delta is nothing but change in y. Like that here, that change in x. Now this can be, this delta y by delta x can be even calculated. This delta y by delta x will give what? The slope. The slope can be even written in this form. This x-axis, this line, this delta x. For this, the reference line is x-axis. For this, the reference line is x-axis. So the angle moves from this line to this. So it becomes theta. The delta y is nothing but what? For this angle, delta y is opposite and delta x will be equal to adjacent. So this opposite by adjacent, I can call it as tan theta. Now, in a straight line, if I take an angle, all the angles will be equal. That means the tan theta will be equal to what? Constant. The angle will be constant. So the slope will be constant. For a straight line, the slope is constant. But in a curved line, you see here the angle, in this angle, the angle goes on increasing. As the angle increases, the theta value is also increased. Therefore, the slope will varies in a curved line. The slope will varies in a curved line. The slope will be constant in a straight line. So slope will be constant in a straight line and slope will varies in a curved line. Now, if I apply this for all the values of theta, the value will be answer will be what? The answer will be positive. The answer will be positive. Understood? That is, from line starts from 0 to this. Suppose now the line is like this. So this is x-axis, y-axis. Now for this line, this point, so I can write this one is what? This point x1. If I take this point, this will be what? x1. This will be y1. If I take this point, there is lines from top to bottom. x2, y2. How to write the slope? Slope is equal to what? y2 minus y1 by x2 minus x1. Now see the value. This is 0, 1, 2, 3, 4. Here it is, for example, 1, 2, 3, 4, 5. Now you substitute the value here. What is the value of y2? 3. y1 minus 5. x2 4. x1 1. You see here minus 2 by 3. So you are getting negative. So therefore the slope will be negative when line moves from top to downwards. Clear? Next, now if the line is horizontal to x-axis, what will be the slope? Now here x1, y1, x2, y2 also in the same line, so I can write y1 is equal to y2. So what is the formula for slope? y2 minus y1 by x2 minus x1. So what is y2? y2, I can write it as y2. y1 is nothing but what? y2. So I can write y2 minus y2. This one x2 minus x1. So 0 by any number will give 0. In 0 by any number will give 0. Therefore, for horizontal line, the slope will be 0. Next, suppose if the line is vertical, that is parallel to y-axis. Now what will be the slope? x1, y1, for this point x2 and this one is y2. Here x1 is equal to x2. So y2 minus y1 by x2 minus x1. Here y2 minus y1. But here x1 is equal to x2. Therefore x2 minus instead of x1 I can write it as x2. That is y2 minus y1 by x2 minus x3 is 0. Any number divided by 0 will give infinity. Any number divided by 0 will give infinity. So therefore, if the line is vertical, then the slope is infinity. If the line is parallel, the slope is 0. Clear? Now we will find the slope with respect to x-axis and with respect to y-axis. Now horizontal line. Now I want to find out the slope with respect to x-axis. So slope is equal to delta y by delta x. With respect to x-axis means x will be down. This is how we can write y2 minus y1 by x2 minus x1. Here x1 is there, x2 is here, but y is constant. Y is equal to 0. So 0 by anything will give 0. So with respect to x-axis, slope will be equal to 0. Suppose with respect to y-axis, slope is equal to delta x by delta y. Here x2 minus x1 by y2 minus y1. So here x2 by x1. So x2 minus x1. So y2 minus y1 is 0. So any number divided by 0 will give infinity. So for horizontal line, with respect to x-axis, the slope will be equal to 0, and with respect to y-axis, the slope will be equal to infinity. Now, we take the vertical line. Here, with respect to x-axis, what will be the slope? So slope is equal to delta y by delta x, that is y2 minus y1 by x2 minus x1. Here x1 is equal to x2, but here y1 is the y2 is here. So I can write y2 minus y1 by x2 and x1 are equal, so x2 minus x1 is equal to 0. So any number by 0 is equal to infinity. Now with respect to y-axis, slope is equal to delta x by delta y. So I can write x2 minus x1 by y2 minus y1. Here 0 by y2 minus y1. So 0 by any number will give 0. So for vertical line, with respect to x-axis, slope is equal to infinity. With respect to y-axis, the slope is 0. Now, let us consider three lines. 1, 2, 3. Let us consider A, B, and C. With respect to x-axis, how the slope will be? Let this one is theta 1, this angle is theta 2, in this theta 3. Which angle is greater? Theta 3 is greater. So slope of part A is greater than this one. Slope of B is greater than slope of C. Now we go to with respect to y-axis. A, B, C with respect to y-axis. So theta 1 will come this side, theta 2, theta 3. Now which angle is greater? Theta 3 is greater along with C. So I can write slope C is greater than slope B, which is greater than slope A. Understood? Thank you. How to find out the slope of a curve at a particular point P? So we know that the slope of a straight line, how to calculate? So 2 points, and this is delta y, delta x. So slope is equal to delta y by delta x. So this is the way how to find out the slope of a straight line. Now I want to find out the slope of a curved line. So what I should do? I must draw a line. How to draw a line? Now let us get a small, very small line on this curve. Let us consider very small line on this curve. Now you take a particular line, you extend that line. This line is nothing but what? Tangent line. So from this we can able to find out the slope of a given curve. Okay. Now if you take this curve, I want to find out the slope of P. How to find out? So you must just draw a line. Now this is the curve P and Q. Now I want to find out the slope of this point P. Now you draw the line. This line passing through P and Q is nothing but secant line. It's nothing but what? Secant line. Now I should reduce or I should convert this secant line into a tangent line. How to convert? Just reduce the distance of PQ. If you reduce the distance of PQ, you see here delta y and delta x goes on decreasing, and finally this P and the Q, the distance is very small, so it looks like a particular point, and that it forms what? A line. Thus, this line is called as tangent line. From this, we can find out the slope for a particular point P. Now, we will find out this delta y and delta x goes on decreasing. That means delta y tends to 0, like the delta x tends to 0, but they are not equal to 0. Now, what will be the position of P and position of Q? The function, what is the function? Y is equal to x square. Now, this is x. So, if y equal to x square means, that is, what will happen? Y is equal to, substitute the value of x. So, once again we get y equal to x square. So, here it becomes what? X square. Now, this point from x, it has been changed to here. So, the change is delta x. So, like that for y, it is delta y. What will be the position of this point? So, y is equal to, what is the value of x now here? X plus delta x. X plus delta x whole square. So, what the position is here what? X plus delta x. This one is x plus delta x. So, the point in this x axis is x plus delta x. For this, what will be the y axis? So, the y axis will be equal to x plus delta x the whole square. Clear? Now, here the point is x comma x square. Here the Q point is x plus delta x comma x plus delta x the whole square. Now, I want to find out the slope for T. y2 minus y1 by x2 minus x1. What is the value of y2? This is x1, y1, this one is x2, y2. So, y2 is what? X plus delta x the whole square minus y1 is what? X square divided by x2, x plus delta x minus x1, x. This x and x cancel. This a plus b whole square formula. X square plus delta x square plus 2x into delta x minus x square divided by delta x. This x square minus x square cancel. So delta x square plus 2x delta x by delta x. Here delta x tends to 0. So this delta x square is very small. So I can neglect this delta x square. So therefore I will get two x delta x by delta x. This one is neglected. So when delta x tends to 0, so I can write limit delta x tends to 0. This delta x and delta x cancel. This will be equal to what? 2x. This 2x is nothing but derivative of that is dy by dx. So next example 2.18. Here the function is given y equal to x square and they ask to find out dy by dx. This is a graph for this function. Now let us consider 2 points. If x1 is equal to 2 and x2 is equal to 3. For this values we will find out dy by dx. Here it is given in the tabular form. Just I explain it. x1 is equal to 2, x2 is equal to 3. How to find out y1? We know the value of one function y is equal to x square. What is the value of x1? 2. So 4. So x1 is equal to, that is y1 is equal to 4. Now similarly x2 is equal to 3. Substitute 3 square, it becomes 9. Delta x, x2 minus x1. So 3 minus 2, 1. Delta y, y2 minus y1, 9 minus 4, 5. Now you divide delta y by delta x, 5 divided by 1, it gives 5. So like this we will calculate. From this, what we infer? From this we infer that as delta x decreases, that is it tends to 0, dy, that is delta y by delta x goes to 4, that is dy by dx at x is equal to 2, the value is 4. So from this you can calculate dy by dx. Now in general, if I want to differentiate y equal to x square, how I can write? Dy by dx is equal to 2x 2 minus 1. So I can write 2 into x. So similarly, I can write for x cube. So dy by dx is equal to 3x 3 minus 1. So 3x square. So in general, there is a formula. You can write a formula for this. Y is equal to x power n. I can write n x n minus 1. This is a general formula for differentiation. So example 2.19. So x is equal to a0 plus a1t plus a2 t square. They also find out, or they also differentiate with respect to t. So I can write dx by dt is equal to a0 is constant, so 0 plus a1 t if I differentiate 1 plus a2 if I differentiate t square it is 2t. So I can write a1 plus 2 a2t. So we are differentiating with respect to t. So that t is there. So once again we have to differentiate. I can write d square x by dt square equal to a1 if I differentiate 0. So 2 a2 if I differentiate t is 1. So it is 2 times of a2.